Okay, so in this problem, it said that a girl threw a newspaper at the force of 40 meters per second and a degree of 60 degrees. So first of all, to get the magnitude of the force of the initial velocity in y and x, we have to calculate with sine and cosine function of this magnitude. As we said right here, we have the 40 meters per second force like in diagonal, so that's not good for us, like no use. We don't have to use that, and we only calculate the 14 times sin of 60, so we get that the initial velocity in the y in the free fall exercise, it's 12.12 meters per second, and we do this exact same thing but with cosine, and we get 7 meters per second in the x-axis. So now that we have these two, you could say, initial velocities, we first use the 12.12 meters per second so we can get the time in which the newspaper will get from traveling to here, from here to here. So we have this formula, which is the final velocity is equal to initial velocity times plus gravity times time. So we have our our final velocity, that it's going to be 0, because when it reaches like the maximum point, it will be 0 of the velocity in y, in the y-axis. So we have 0 is equal to initial velocity, that it's 12.12 meters per second, plus gravity, that it's 9.8, well, minus 9.8, and times time. So we only have to let time alone, and it's going to be 1.24 seconds in time. So now that we have this, you could say, time in that it travels from here to here, we only have to get the distance in the x-axis, because we already know the velocity in the x-axis, which is 7.7 meters per second. So with this formula, that is velocity is equal to distance divided by time, we only let distance alone, and it's going to be velocity times time. So it's going to be 1.24 seconds times 7 meters per second, and that lets us with a distance of 8.68 meters in the x-axis, only from here to here. And now we need to calculate the distance from here to here. Now that brings us to the second part of the exercise, which is also this. So first of all, we need to get also the height from here to here, because if we calculate that height, then we add the 1.68 meters that you could say that it's her height. And okay, we have the procedure here, that we use this formula that indicates that the distance in y is going to be the initial velocity times time plus half of gravity times time squared. Okay, and if we substitute all those values, we have the distance, that it's it's 7.49, but when you add the extra 1.68 meters that she is tall, so you get 9.17 meters. So basically from here, that it's the maximum point to the floor, you could say, you have the 9.17 meter distance. Now that brings us to this, which is that we already have the distance, and we have that our initial velocity is going to be 0, like in free fall. And we have the acceleration, which is gravity, and these are going to be the formulas that we need to calculate the total distance. So now we have that the distance in y is going to be initial velocity times time, but because the initial velocity is 0, this is going to be cancelled, and it's going to be plus a half of gravity times time squared. and we don't have time. So time will be equal to the square root of 9.17 divided by half of gravity, and that leaves us with 1.37 seconds. And once we have the time, we only, as we did like here, we are only going to let distance alone, which is going to be velocity times time, and it's going to be 7 because the velocity in x never changes because we don't have like air resistance in consideration. And we have that it's 7 meters per second times 1.37 seconds, and that leaves us with 9.59 meters. And that's going to be our distance from here to here. It's going to be from here to here, sorry. And now we have the distance from here to here and the distance from here to here, and we only need to add them up together, and it's going to be 9.59 meters plus 8.68 meters, and that gives us a total distance of 18.27 meters. And that's basically it.